Have you ever wondered what would happen if dangerous germs ended up in the wrong hands? Or just got out by accident? Yeah, it sounds like the plot of a sci-fi movie. But managing biological risks, what's called biorisk management, is something that happens every day in labs across the world. So what exactly is biorisk management? It's all about making sure that the work we do with bacteria, viruses, or even genetically modified organisms doesn't turn into a public health problem. Think of it as a giant safety net made of rules, equipment, training, and a hefty dose of common sense. The first layer is biosafety. That's about keeping the people in the lab safe, using protective equipment, proper procedures, and some pretty strict protocols. Ever seen someone put on 3 pairs of gloves before opening a test tube? That's biosafety in action. Then there's biosecurity. This is about keeping those samples out of the wrong hands. Locked freezers, restricted access, inventory checks, like a secret agent movie but with petri dishes. But here's where it gets interesting. It's not just about rules, it's about culture. The best labs encourage people to speak up if they spot a risk, report mistakes, and constantly look for ways to improve. Because, let's face it, nobody's perfect. And as science evolves, think CRISPR synthetic biology, the risks get trickier, and so do the solutions. That's why biorisk management is never set and forget. It's an ongoing process. So next time you hear about a breakthrough in biology, remember, there's a whole world of careful planning, training, and teamwork happening behind the scenes to make sure those discoveries help, not harm. Curiosity might drive science, but safety keeps it moving forward. Let's take a closer look at what makes biorisk management tick. It all starts with 3 key concepts: hazard, risk, and exposure. Imagine a hazard as anything in the lab that has the potential to cause harm, like a vial of infectious bacteria. Risk is the chance that this hazard will actually cause harm, say if that vial gets dropped. And exposure? That's what happens if someone comes into contact with the bacteria, maybe through a spill or a splash. But how do labs keep these dangers in check? Enter the hierarchy of controls, a step-by-step guide to making the workplace safer, starting from the most effective measures down to the last line of defense. At the very top is elimination. If you can completely remove the hazard, you wipe out the risk. For example, if a certain experiment isn't necessary, just don't do it. Problem solved. Next is substitution, replacing a risky agent with something safer. Maybe a harmless strain of bacteria can be used instead of a dangerous one for training exercises. Then we have engineering controls. These are physical changes to the lab environment, like using biosafety cabinets to contain aerosols, or installing hands-free sinks to reduce contact with contaminated surfaces. Administrative controls come next. These are the rules and procedures that help people work more safely. Think detailed lab protocols, regular safety training, and clear warning signs. And finally, personal protective equipment, or PPE. This is the gear you see in every lab gloves, lab coats, eye protection, and sometimes even full-body suits. PPE doesn't remove the hazard, but it helps shield you from exposure if all else fails. By layering these controls, labs build a strong defense against accidents and mistakes. It's not just about ticking boxes on a checklist. It's about creating an environment where everyone goes home safe every day.